Hi, Jovan.
Hi, sir.
Okay, yeah.
Attention, please.
Varghese Philippachan.
സാറേ പ്രാർത്ഥിക്കട്ടെ. നമുക്ക് പ്രാർത്ഥിക്കാം. ദൈവമായ കർത്താവേ, തിരുസന്നിധിയിലേക്ക് ഞങ്ങൾക്ക് ഒരുമിച്ച് അടുത്തുവരുവാനുള്ള കൃപ തന്നതിനായി സ്തോത്രം. ഇന്നത്തെ ഞങ്ങളെ സെമിനാർ ഏറ്റവും അനുഗ്രഹീതമായി നീ തീർക്കണമേ. ഈ ആധുനിക കാലഘട്ടത്തിൽ എങ്ങനെ ജീവിക്കണം, ഏത് രീതിയിൽ പ്രവർത്തിക്കണം, എങ്ങനെ ഓരോ കാര്യങ്ങൾ പ്രതികരിക്കണം എന്നുള്ളത് പഠിക്കുവാനുള്ള അവസരമാണല്ലോ. അത് ക്രിസ്തീയ മൂല്യത്തിൽ അടിയുറച്ച് ദൈവദർശനത്തോടെ, ക്രിസ്തു ഞങ്ങൾക്ക് തന്നിരിക്കുന്ന നല്ല ദർശനത്തോടെ ജീവിച്ച് പ്രവർത്തിപ്പാൻ സഹായിക്കണമെന്ന് പ്രാർത്ഥിക്കുന്നു. ഇന്ന് ഞങ്ങൾ സയൻസ് ആൻഡ് ടെക്നോളജി ഒക്കെ വളരെ ഡെവലപ്പ് ചെയ്തിരിക്കുന്ന ഒരു കാലഘട്ടത്തിൽ ജീവിക്കുമ്പോൾ അത് മനസ്സിലാക്കി അതിനനുസൃതമായി ജീവിപ്പാനും പ്രവർത്തിപ്പാനും ഞങ്ങളെ സഹായിക്കണമേ. ഇന്നത്തെ ഞങ്ങളുടെ സെമിനാർ ഏറ്റവും അനുഗ്രഹീതമായി നീ ഞങ്ങൾക്ക് നൽകണമേ. ഇതിന് നേതൃത്വം കൊടുക്കുന്ന എല്ലാവരെയും ദൈവം അനുഗ്രഹിച്ച് ആശീർവദിക്കണമേ. എല്ലാവരും കർത്താവെ അനുഗ്രഹീതമായ നേതൃത്വം കൊടുക്കുവാനും അത് ഇതിൽ പാർട്ടിസിപ്പേറ്റ് ചെയ്യുന്ന ഓരോരുത്തർക്കും പ്രയോജനപ്പെടുവാനും അത് ഞങ്ങളുടെ പ്രവർത്തന മേഖലകളിൽ വ്യാപിപ്പാനും സഹായിക്കണമേ. നിന്റെ കൃപയ്ക്കായിട്ട് ഞങ്ങൾ പ്രാർത്ഥിക്കുന്നു. ഞങ്ങളെല്ലാവരെയും അനുഗ്രഹിച്ച് ആശീർവദിക്കണം. തിരുസാന്നിധ്യം കൊണ്ട് ഞങ്ങൾ നിറയ്ക്കണമേ. യേശു കർത്താവിന്റെ നാമത്തിൽ ഞങ്ങൾ അപേക്ഷിക്കുന്നു. കൃപയുടെ കേൾക്കുമാറാകണമേ. ആമേൻ.
heart adore you. Hope of a life spent with you. Here I am to worship. Here I am to bow down. Here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether wonderful to me. King of all days, oh so highly exalted, glorious in heaven above. Humbly you came to the earth you created, all for love's sake became poor. Here I am to worship, here I am to bow down, here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether wonderful to me.
A very good evening to one and all participating in today's lecture series. I'm Jobin, a student at Rajagiri Krishna Jayanti Public School, Kakinad, Kochi, and I'm honored to have been entrusted with today's welcome address. If your actions inspire others to dream more, learn more, and become more, then you are a leader. These wise words were spoken by the 6th American President, John Quincy Adams, perfectly defined Dr. Jobin Syriac, who, despite his busy schedule, set apart some time to educate us on the amazing world of nanomaterials and inspire a new generation of young teens. Dr. Jobin Syriac is an associate professor of chemistry at the Indian Institute of Space Science and Technology, Trivandrum. He is a specialist in mass spectroscopy and nanotechnology. He earned his BSc and MSc degrees from MG University Kottayam and PhD from IIT Madras. His PhD research was on low-energy ion scattering, for which he developed an ultra-high vacuum ion surface collision instrument, one of the first of its kind in India. Dr. Jobin did his postdoctoral studies at Aston Labs for Mass Spectroscopy, USA, where he developed novel methods to prepare nanomaterials. At the IIST, he is exploring various applications of 2D materials, surface-enhanced Raman spectroscopy, mass spectroscopy, and ion surface collision phenomena. He has authored 36 papers in international journals and delivered at least 30 invited lectures. He is the proud recipient of the Young Scientist Award of the Indian Society for his work in mass spectroscopy and the Marthoma Artumanil Young Scientist Award. It is my due honor to welcome him to this platform today. I cordially welcome Reverend Varghese Philip, Vicar at Para Emmanuel Marthoma Church, who blessed us with the opening prayers, and Reverend C.K. Titus, who would be offering the closing prayers. I most sincerely thank Reverend Dr. K. Jameson, the Associate Director of JMM Studies Center, and Professor Dr. K. N. Nainan, a former outstanding scientist of VSSC and the convener of this program, for making available to us this wonderful learning experience. Welcome, sirs. It is my pleasure to welcome Dr. Deepthi Shivadas, a scientist at VSSC, who will be coordinating today's QA session. None of this would be possible without the support of the technical and media team, who are responsible for ensuring the seamless conduct of the Zoom meeting and YouTube streaming. On behalf of everybody participating in today's lecture, I would like to graciously thank them all for their service as I welcome them to today's program. I graciously welcome all parents and teachers present here today, without whose encouragement and guidance, many of us wouldn't be here today. Last, but not the least, I would like to genially welcome all my fellow students who are present here today and thank them for their active participation and involvement in this program. The mind is not a vessel to be filled, but a fire to be kindled. Now, with these wise words from the Greek Platonist Plutarch, I would like to turn the spotlight over to Dr. Jobin Syriac, so he may kindle the fire in our minds.
Thank you, Jovan. I'm audible, right?
Yes, yes, yes.
So good evening to all. Maybe if those who are attending from other part of world, good afternoon and good morning. Let me start with thanking all the organizers to giving me this wonderful opportunity, especially Reverend Dr. James Sanachan and Dr. Nainan sir, whose ideas and efforts made this program into reality. Also, thank you, Jovan, for your wonderful introduction. It was very good. Thank you very much. I thank the Father Varghese Sachan, Reverend Father Varghese Sachan, for offering the opening prayers. So let us start today's talk. As you have seen, or you can see. So the title of today's presentation is The Amazing World of Nanomaterials. So today we are going to talk about nanomaterials, a class of materials. And I have written a second line also, big thing from tiny world. This means that big science can happen using nanomaterial. Nanomaterials are small or tiny materials. So that is why I have used the term tiny world. So what is nanomaterial, or what is the importance of nanomaterial? Why is it important, etc. We will see in this during this talk. And whether it is amazing or not, towards the end of the talk, you yourself may decide whether it is an amazing material or a normal material. Before getting into today's discussion or today's topic, let me introduce my own workplace, my institute where I work. It is the name of the institute is Indian Institute of Space Science and Technology, which is coming under ISRO or Department of Space. Fairly, this is a new educational institution started in 2007. And some of you may be knowing that Dr. Naina and others are the main people acted or instrumental in the beginning of this institute. It started in 2007. Main courses, important courses teaching courses here is BTech in aerospace, BTech in avionics and physical science, along with MTech courses and PhD program is there. So this, if you get admitted into BTech course, it is a good chance you to get into the scientist or engineer in ISRO directly. So without much difficulty, you will be able to absorb into ISRO. So if you would like to know more about, please visit this website. So let us start talking about nanomaterial. So in the screen, what you are seeing is Spider-Man. So it's a superhero. All of us are familiar with this superhero. Why is he superhero? What makes him as a superhero? All of us know that the spider fiber, which he produced instantly, and it is attaching to this building and other things, and he can jump from one place to other place. So the reason he become the superhero is one material, which may be spider's web, as well as his suit is also important. So in the recent Spider-Man movies, the suit is getting it is getting updated with various materials and various capabilities. Similarly, if you look into various other science fiction movies, especially from Hollywood, like Iron Man, another superhero who becomes hero because of who become a hero because of his suit or armor, which is made out of a special kind of material. And some of you may be knowing that every movie, this armor getting updated, and several versions are there. So these are the stories of superhero made or heroes, person who becomes heroes because of power of material. Similarly, the villains are also there. So he is the villain from Terminator movie, Judgment Day, Terminator 2, as well as other Terminator movies are also similar villains are there. What is a speciality about this villain? He's a super villain. Why? Because of the material which he was made of. He is not a real human. He is made out of liquid metal. And whatever the shots you are seeing in his body is the bullet shot made by maybe the hero, but still he is not dying and within a few seconds or few minutes he is coming back to his original shape. So it gives him a super power, a super villain power. So these materials are, this example shows the fascinating world of material. The these materials may be futuristic. So that is what we are calling, or I can tell you as materials are smart, or you can become smart by utilizing the material. So the bottom picture is from the Avengers final movie, where the Iron Man suit is it is called Mark 85. That means 85 times modified, and it has various capabilities. And interestingly, the American Chemical Society, which is the largest chemical society in the world, they suggested the material for making this Mark 85 suit for Iron Man. And they have suggested materials, they selected materials from smart materials like nickel, cobalt alloys, as well as various kinds of nanomaterials we can incorporate into the suit, and it will give the superpower. So materials are smart, as well as it is having very important role in human history. That you can see, or that you can understand from the division of ages, like the human civilization itself, or human history itself, is divided into Stone Age, Bronze Age, and Iron Age. So this is the picture which whatever is showing is the devices or the arms or whatever equipment they have, people or men have been made utilizing the stone or rock materials. And after the Stone Age, the Bronze Age came, where bronze was the main material for the utensils, and Iron Age, and later maybe in the present age you can call it as a technology age, or semiconductor age, or electronic age. There is no specific name for that, but still these are the various kinds of classification according to the material which human being or mankind used for their usage. Now, at the present time, we cannot think of living without a material. Every time or every second, we are using one material or other material, or we are surviving with the help of one or the other materials. So here I have just listed it out. So many materials we are coming across in everyday life, maybe aerospace material, biomedical material, electronic material, where we light up using in the light, various methods, computer related materials, and materials using for the structural application. So these are the common materials. So I have not yet come to nanomaterial. Okay, these are the common material we use in everyday life. So these figures tells you that these materials are very important to our life. Now, I have come to this point, nanomaterials. So you can see the writings, nanomaterials. So materials is there. So if you look close, I have divided into two things, like one is nano, one word nano, the other one is materials. Materials, you don't have any introduction. So any materials you can think of, maybe polymer material or maybe metallic material, metals, non-metals, or any kind of material you can think of. So what is this nano stands for? So that is the question. So nano is a prefix, like it represents nanometer. It is like a centimeter, millimeter, Similarly, nanometer is a prefix which represents a particular size range. So what is nano then? So nanometer is 1 nanometer. The representation of a nanometer is just write N and M like meter. So it is the unit in nanometer. And nanometer is 10 to the power minus 9 meter. Or you put a point or decimal point and write 8 zeros and 1, or 1 billionth of a meter. So that is mean by 1 nanometer. So the materials or particles which is having this size range, maybe 1 nanometer to 100 nanometer, is defined as nanomaterials. Maybe in the subsequent slide discussion, which is I'm going to do it in the subsequent slide, you may understand in more details what is nanomaterials. Or otherwise, maybe the most common picture nowadays, coronavirus picture of, maybe this is the pictorial representation of coronavirus. What is the size of coronavirus? The diameter of coronavirus is almost maybe 100 nanometer. So you can call coronavirus as a nanoparticle. So because its size is 100 nanometer. So this is the size range, or what is meant by nano or nanometer. I will further explain. All of you are playing cricket. So I have given a picture of a cricket bat. What is the length of a cricket bat? Almost 1 meter. Consider it as 1 meter. Now take cricket bat and divide into 100. So that is almost equivalent to your nail, almost 1 centimeter. Your nail size is almost 1 centimeter. Then further you divide the size of the nail to 10 times. So then you will get a size of a pen nib, or the point which you made using the ballpoint pen. So the size of this particular point made on the paper is 1 millimeter. Further, you divide into 10, and this is the picture of our hair, our own hair. So what is the size of the hair? Hair size is 100 micrometer. 100 micrometer. Micro is 10 to the power minus 6 meter. So the picture, whatever you are seeing, is the size of maybe the picture of hair, which is taken in a microscopy. So it is magnified and shown you. So the size of the hair may be the minimum size you can see using your normal eye. So if you want to see smaller things, you need to have what microscope or magnifying lenses or microscopes are necessary. Now you can imagine the size of your hair, which is 100 micrometer. Again, take the hair and divide it by 10. So you will get the size of our own red blood cell. It is approximately 10 micrometer. Then further you go on dividing into red blood cell into 10 times. You get 1 micrometer, which is the size of a bacteria, or which is size of the bacterium. And further, if you divide 10 more times, which is size of our coronavirus, the size of the coronavirus, 100 nanometer. Then again, if you divide 100 times, you will get approximately 1 nanometer. So which is the size of our DNA, or the deoxyribonucleic acid, our protein size. So the diameter of this DNA strand is 1 to 2 nanometer. The nanomaterials are coming in this range, size range, 1 nanometer to 100 nanometer. So when you see say carbon nanomaterial, or maybe the other one, silver nanomaterial, the size of the particle which is composed of that material is what? 100 nanometer, or between 1 nanometer and 100 nanometer. And you can go on further dividing or maybe reducing the sizes. If you reduce the size of 1 nanometer by 5, then you will get 0.5 nanometer, which is size of maybe benzene molecule. Benzene, maybe those who are studying in high school level, everybody knows the molecule benzene, and the size of the water molecule is 0.1 nanometer, and size of a carbon atom, single carbon atom, is 0.07 nanometer. So here you should understand that by seeing this material, you need to have a special microscope. Otherwise, you won't be able to see this material. And till maybe the human hair, you can observe using your naked eye without any microscope. All other things you need to have microscope to investigate or see the things. So further, I will define. So whatever we have discussed is that this size range, 1 nanometer, which is almost a size of a molecule, to 100 nanometer, which is the size of a coronavirus or virus, is this size range particles or materials are called as nanomaterials. Now, I imagine that I assume that all of you have got the definition of nanomaterial, the particles or the material which is having the size ranges in this ranges in this range, like 1 nanometer to 100 nanometer. During the further discussion, you may get more understanding about nanomaterials and why it is important, etc. So here I will give a simple example, very common or very easy to understand. So what happens in the nano range or nano regime? So here, whatever you are seeing is a gold plate or maybe gold biscuit. You call it as a gold biscuit. So gold biscuit is dissolving in acid medium. So if you take an acid in the test tube and put a piece of gold, then it will start dissolving it. So what is the color of the dissolved gold or the bulk gold or whatever your gold ornament? It is kind of yellowish color. So this is very familiar to you. The color of the gold is yellow. But you can prepare gold nanoparticle using chemical synthesis method by chemical reactions. And the color of gold nanoparticle is not yellow. So here I have given 2-3 bottles. So 10 nanometer means 10 nanometer sized particles. The size of the gold particle is 10 nanometer. So the color is, maybe you call it as wine red or red, intense red color. The particle size, which is confirmed using a microscopic image, is also given here. So here you can see that this the scale bar is given, and this is in the range of 10 nanometer. So one particle size is 10 nanometer. So there are methods to synthesize or prepare this particle by means of chemical reactions. So here, what property changes you have seen? What is the interesting property? From the bulk gold, when it is changed to nano gold, the size is, or the color is changed. So one property, which is color. Similarly, various other property will be changing. So this already we have mentioned. We defined nanometer and we defined what is nanomaterial. And the nanomaterial is the usage of this nanotechnology is the usage of this nanomaterial for various applications. These nanomaterials are having various properties, various interesting properties. Some of you will come across during the next slides. So utilization of this nanomaterial for various applications, we can call it as nanotechnology. And nano in general, or nanomaterials in general, refers to a material or particle or any maybe biological particles like DNA or those kinds of liposome, etc. So it is in the nano size range. So those materials, those objects, you can call it as nanomaterials, and nanotechnology utilizes the nanomaterials. So further to get understand what is nanomaterials in the material aspect, you just consider a rock, maybe which you can hold on in your hand, something like a 1 kilogram weight. You imagine a rock piece. So this is the bulk material. You call it as bulk rock, bulk silica or bulk rock, and you can powder it. It becomes sand. So what is the size of the sand particle? Maybe 1 millimeter. It is still in visible range, or we can see the one particle of sand, and this is in 1 millimeter range. If you further divide or further powder it or further make fine powders using various mechanical method, so you will be able to make sand in nanometer range, like 100 nanometer size. That you can call as either nano rock, depends on you, nano sand, or nano silica. Silica is the chemical name of sand, SiO2, so you can call nano silica also. So this is in the powder form of nanomaterial. So it is not necessary that the nanomaterial should be in powder form. The earlier solution of gold, whatever you have seen, is in solution form. So that you call it as suspension. So the same silica, after proper chemical treatment, you can make dispersion or suspension. So this particle will not settle because of the chemical treatment, particular chemical treatment or chemical reactions you can conduct, and then this particle will not settle it. Similar to the milk. Milk contains a lot of proteins, but you never see it is settling down until and unless you add maybe some acid or some, if you change the pH only, it will settle. So as long as that, it will be stable. So similarly, you can have powder nanomaterials in powder form as well as nanomaterials in dispersion form or solution form. So continuation of the discussion in the previous slide. So here the common thing which is very familiar to you, like iron nails, which is made out of iron. You call them as bulk iron, and you can have iron in nanoparticle form also, or nano-sized iron. So this can be in just nano-sized iron, which is just Fe, or various combination or various compounds of iron, like iron oxide. So this image also, it is showing you that the size of this particle. So this, whatever this black particle is the nanoparticle of iron, which is having maybe 50 nanometer size. So whenever you see a microscope, you can see that microscope image. There is a scale bar here. That means this distance represent this this many, I mean 100 nanometer size in this distance, or this is the scale bar. So the particle size is less than 100 nanometer in this case. So now I hope that all of you got what is a nanomaterial. So we have seen nano gold, we have seen nano sand, maybe, and we have seen nano iron. So similarly, you can think of any nanomaterial from the biology also, nanoproteins or liposomes. All those things are also in nano size range. Or in other words, maybe from the plastic side, polymers, or from other materials like porcelain pieces. All these things you can think in terms of nano size. And what happens when you prepare a nanomaterial, or as we have seen in the case of gold, when it is in nano size range, the color changed. Similarly, various properties change. The material's property itself changes, and it gets maybe sometimes exotic properties. So that is why we use nanomaterials. So some of the properties I will explain here. So maybe 5 properties or 5 things I have listed it out. The first one is high surface area. So imagine that a tennis ball, and a tennis ball sized particle. And if you further divide it into several pieces, several small pieces, the surface area of that particle is increasing, or surface area of the material is increasing as you reduce the size. So that is why it is called, or it is referred as, surface to volume ratio is very high. Then that means you are having lot of atom in the surface, lot of atom available in the surface. That gives you more reactivity, or it changes its reactivity. And again, because of the size reduction, its electrical property change its optical property. Optical property means the color or the property which is related to the interaction of light. Mainly you can think of color. And the another important aspect is the size range of these nanomaterials comes to the biological structures. So those aspects I have again explained here. So what is how surface area, or why surface area is important? Maybe just a simple example I can tell you. You imagine eating of a chocolate. So what are the ways? We can just take one piece of this chocolate and without biting it, you can swallow it. Do you feel good taste? No, because your tongue is not interacting with your chocolate pieces. Very small taste only you will be feeling. Instead, if you bite 2-3 times and break the chocolate piece into 2-3 small pieces, what will happen? The surface area of chocolate pieces increasing. From the one piece, compared to one piece chocolate, the surface area of chocolate is increased by dividing into several pieces. When surface area increases, what happens? Your tongue is able to, whatever the sensor which is available in your tongue is able to detect the taste. So you get more taste. So if you want to enhance the further taste, you just chew it. Just to chew it, taking more time, you just chew it. So you'll be having more taste. So that means more surface area. You are getting more surface area. More atoms are exposing into the surface. So similar is the case with the nanomaterial. When it comes to small size, the surface atom, the number of surface atom is increasing. As a result, the chemical reaction, the reactivity capability of its reactivity is increasing, changing. Sometimes it may increase, sometimes it may vary differently. So that is the importance of surface area. Now, what is mean by electrical properties or optical property? Here again, those who are maybe still you are not learned about the electronic energy band structure. So when you consider a metal, you know that it is made out of elements. For example, if you take silver, so silver element is made, or silver metal is made using silver element, which is having electrons. So when it forms the metallic silver, there are free electrons available. So that make the silver as a conducting material. And these electrons are in particular energy level, energy state that is defined by quantum mechanics. So those aspects anyway, you don't have to understand that, but just understand that these electrons are staying in a particular energy level. And this energy level of electron can be increased by absorbing light from the external light, from the visible light or the other lights. So this electron can be excited from ground level to an excited level. So by doing this job, what the material is absorbing some light. So that can be varied in the nanoparticles. So this light absorption capability can be varied. You know that the bulk silver, what is the color of this normal silver ornament? You can tell that it is white or not particular color. It is only showing the metallic luster. But when it comes to silver nanoparticle, as in the case of gold, it is changing its color because of the fact that the light absorption capability of this material is changing. So that has a lot of application in both in electronics materials as well as in optical materials. And further, as I mentioned that the particle size is similar to biological structure. So it gives a lot of opportunity to work in medicine field or biological field. This nanoparticle or nanomaterial can be used in medicine because most of the biological structures are nano size, like liposome. This is the liposome, and this is the DNA. The diameter is almost 2 nanometer, and the size of the red blood cell is almost 5,000 nanometer. So if you have a nanoparticle, you can use it in your body for various purposes because the size range is in nanometer, which is similar to biological structures. So these are the aspects why nano is important or why nanomaterial is interesting. So now I'm moving to, so we have defined nanomaterials and we have seen what happens in nano regime, what properties are getting into materials, or what are the important properties of materials in nano range. And now we will see where is it available or how to prepare this nanomaterial. So some of the preparation method I will just mention, but here what I am trying to say is that these nanomaterials, it is not only you need to prepare it, it is already several nanomaterials are available in nature. It occurs naturally. And incidentally, human activities generate nanomaterial, can generate nanomaterial. And of course, you can intentionally prepare nanomaterial, or you can engineer the nanomaterial. So this aspect we will see. So nanomaterial can be prepared in various ways. So what are the ways? How to prepare nanomaterial or how to manufacture the nanomaterials in various ways. So that is what we are going to see now. So as I mentioned, it occurs naturally. So for example, the size of the carbon materials in smoke or fiber is in this range. So viruses, all these things are occurs naturally. So those are like a class of nanomaterials. Or if you see like incidental activities, like if you, when you burn a candle, so the soot, the carbon soot or the black soot, whatever you have contains nanocarbon particle. So which is having this kind of ranges. So this is a image taken from the carbon soot. And this is also an interesting example where incidentally they have prepared. I mean, it is not intentionally. This is a cup called a Lycurgus cup. Roman emperors long back in BC time, they have used this cup. You don't think of a big size cup. This is a wine glass. Now you are seeing two colors. One is green and the other one is red, right? So the green color is, you are seeing this cup as green color when light is reflected from that cup. And when light is transmitted from the background, you are seeing it as red. Don't think that red light is radiated from the backside. The normal white light is lighted behind this cup and you are seeing red color. So the reason for this one, the manufacturers made this cup by incorporating some nano materials. So they did not know that it will be a nanoparticle because those times Roman emperor's cup, right? Wine cup of an emperor or a king. So it needs some gold. So they have incorporated gold and eventually it formed a nanoparticle and gave this fantastic coloration or very interesting color changes. And also incidental, say, several examples are there from the Ayurveda medicine. Some of you may be knowing the Swarna Bhasma or the Saraswata Arishtam, where the Ayurveda medicine, one of the Ayurveda medicine, Saraswata Arishtam is for good for memory or brain health. So this contains a bit of nano, say gold, and gold in nano forms. So it was earlier not known, but after the it was not intentionally added to form nanoparticle. They added for the need of adding gold, but it formed a nanoparticles, and so that is why I mentioned this as incidental. Or other example is like Damascus sword. So this is one of the strongest and sharpest human sword made by human. And why this has this good strength is because of the presence of some carbon materials. So that came into knowledge. I mean, people came to know about that incorporation of nanomaterial much later. So it was incidentally formed in the processing, during the processing time. And who prepared maybe the nanomaterials like in a systematic chemical synthesis way? So all of you know Michael Faraday. So Michael Faraday, whenever we talk about electronic or physics or electrochemistry, the father of several of these branches of science is Michael Faraday. So here also, so he wanted to study the light passing capability in gold film. So once light is irradiated from one side, how it passes to other side. For making thin gold film, what he did, he treated the chemical, he treated his gold film using some chemicals. Eventually, those solution chemicals or chemical solution is changed color into wine red. So that is the first experimental synthesis or synthetic method or chemical synthesis method of gold or nanoparticle, which is again gold. And whatever he has synthesized 150 years back is still preserved in Royal Society institution where the Faraday Museum is there. So those picture only I have given here. So this nano gold, what he prepared 150 years back is still preserved. So this was happened in 150 years back, and people were not studied nanoparticle properties in very details later. And in 1950s only, again, people started or scientists started thinking about the capability of nano size range. So here also experimental things, experimental synthesis was not done, but a famous physicist, Richard Feynman, who was also a Nobel Prize winner in physics in 1965, he delivered a couple of lectures, which is later known as Plenty of Room at the Bottom. So plenty of room at the bottom. What he suggested is that maybe some of you maybe have seen Encyclopedia of Britannica. Nowadays, everybody uses Google. So this encyclopedia usage is not really necessary. But if you go to any standard library, you can see these several volumes of Encyclopedia of Britannica, where all the informations are available. So this encyclopedia in 1950s, it had 24 volumes and approximately 25,000 pages. So what he suggested is that think of a head of a pin. So if you magnify or if you multiply the size, the diameter of this pin by 25,000 times, if you multiply, then it will be equivalent to 25,000 pages of this Encyclopedia of Britannica. Okay, now you think reverse. If you contract 25,000 pages of Encyclopedia of Britannica to the size of this head of the pin, is it possible? So how can we contract that one? So if you are able to write one letter using 1,000 atoms in this pin head, maybe think of iron, the pin is made out of iron. So if you are able to write one English letter using 1,000 atoms, then you will be able to accommodate this 25,000 pages of Encyclopedia of Britannica in this head of this pin. So that is the suggestion, that is the anticipated result. So this much capabilities are there in this, if you can manipulate atoms in small range or in nanometer range. So that was the beginning of thinking of various types of nanoparticles or nanomaterials and capabilities of nanomaterials. And later, maybe one of the first experimentally prepared nanomaterial is considered as fullerene. So this is the beginning, people are considering this is a beginning of nanotechnology. So what is fullerene? Fullerene is a carbon allotrope, or fullerene is made using only carbon atom. So whatever is the animation, whatever you are seeing here is the black balls are carbon atoms, and that sticks, the gray sticks, is the chemical bond formed between carbon atom. So it looks like so this accommodates 60 number of carbon atom, and this is similar to our football or soccer ball, where you can see hexagon and pentagon. So this is a pentagon and this is a hexagon. So if you count the apex of these polygons in your football, you will find 60 carbon atom. Similar structure. So every apex you will be having a carbon atom. So this was first prepared by, again, 2 Nobel Prize winning scientists, and they got Nobel Prize for inventing this material, Richard Smalley and Harry Kroto. Harry Kroto passed away last year or previous year, and they have named this molecule, or this carbon 60 molecule, carbon 60 number of carbon atoms. So C60 molecule as fullerene, because during that time, one of the famous architect, his name is Buckminster Fullerene. He was famous to have these kinds of dome structures. So these Buckminster's dome structures are famous. So that is why this particular molecule, similar to these domes, right? The structure is almost similar to this molecule. So that way is why this got, it is named as fullerenes. And after that, many nanomaterials have been synthesized, prepared, like gold I already mentioned. So the gold nanoparticle. So when you chemically synthesize nanoparticle, the center will be gold atoms, and it will be surrounded with some organic molecules like citrate, because it has to be protected. Otherwise, it will settle. So you need to have it in the solution. So you need to protect that nanoparticle by covering of some organic molecule. So most of the kind of a gold or silver nanoparticle, you will be seeing a protection using organic molecule, which we call it as ligand or etc. And other one is cadmium sulfide nanoparticle. So when the size of this semiconductor quantum dots or semiconductor nanoparticle, don't worry about the QD letters. So it is also a nanoparticle. When the size changes, so it is having this wonderful color changes. Why it is happening? Because you are changing its energy level. In the previous one of the previous slides, I mentioned that these energy levels can be changed. So the light absorption capabilities are changing. So you know that our blue pen, why is it giving blue color? It absorbs some amount of light or some wavelength of light from the sunlight or our visible light. So that is why it is appearing as blue color. Similarly, this material absorbs some particular color and it is appearing as these kinds of bright colors. As size changes, or you can tune various colors using various sizes of this single type of nanoparticle, or maybe iron oxide. So this iron, the magnetic capability of iron nanoparticle can be utilized using iron nanoparticle. And other one is dendrimers. These are the another kind of nanomaterials. These are polymeric materials. A lot of polymeric chains are there, and it forms dendrimers. But anyway, you don't have to worry about this chemical structure. So it is a long chain chemical structure. Think about that much. Long chain chemical structure, which has this kind of branching, like a tree branch, or in biological liposome. Liposome, some of you maybe have studied in biology this lipid bilayers. This lipid bilayers form this kinds of round structure and shapes, and it is in the nanometer or nanometer range. And other important nanomaterials are from carbon. So only carbon atoms. So here is an example, carbon nanotube. So earlier you have seen fullerene, which is in spherical shape. Now think of only carbon atom in a tubular shape. So here, this black ball represents carbon, and the gray sticks represent, or Yeah, gray sticks represent the chemical bond, the covalent bond between two carbon atoms. So it forms or it arranges carbon like in this tubular shape, and it can have a length up to maybe millimeter or centimeter ranges, but the diameter is in nanometer range, like 1 nanometer. So you can have like a long carbon nanotube, and they have given an image of carbon nanotube. So this is the electron microscopy image of carbon nanotube. Similarly, you can have graphene. Graphene is nothing but single layer of graphite. All of you know the graphite which is present in your pencil, the black material or graphite which is present in your material. So it can be that is entirely made out of carbon, and that carbon is in this structure, like this kinds of structure, carbon atoms, and it is deposited layer by layer. And this layer by layer, if you can peel off one layer, so that you can call it as graphene. So single layer of graphite sheet is called as graphene. So optical image is given here. Electron microscopy image is given here. So this is the microscopic image of graphene material. All these things are having important properties, interesting applications, various applications, etc. are there. I mentioned that seeing nanomaterial is not very easy. So how to, if you synthesize, if you prepared nanomaterial, how do you study? Using optical microscope, like whatever the clinical microscope you may have seen in your biological lab or in clinical labs, this simple microscope. Is it possible to see nanomaterial using this microscope? No. You need to have a high power or maybe better microscope which can have a higher magnification. So those are, one example is electron microscope, transmission electron microscope, where the electron beam is used for imaging the material. In the optical microscope, our visible light, the light source, maybe a bulb is used for as a light source. But in the case of transmission electron microscope, the electron beam is used as for imaging the material. And you will be able to see 1 nanometer sized particle. And this equipment is slightly costly. Maybe it will cost more than 3 crore or 4 crore. And several places in Trivandrum, like even in VSSC, Vikram Sarabhai Space Center, CSIR, NEST, and ICER, and top research institute, they have this capability. That is how they are working in nanomaterials. And another way of seeing nanomaterial is use scanning tunneling microscopy. And invention of this equipment itself is a Nobel Prize winning discovery. In 1986, these two great scientists got Nobel Prize for introducing this particular technique. So what is scanning tunneling microscope? Now you imagine a needle in your, and you rub your hand, your palm with the needle very slowly by looking into what you feel. So the irregularities in your palm can be experienced in that needle, right? When you pass the needle in a line way, in a line fashion, so you can experience the deflection which is happening in the needle. So now think of your arm is electrically grounded, and in your needle you apply 5 volt, and if you come very close to your palm, some electrical current will pass from your needle to the palm. You are not touching, you are just coming very close. So the electrical current will pass. Now you think of moving that needle from one side to other side in a line, through a line, and depending upon the irregularities or the sizes of your palm or the fingerprint, the current varies. So that can be recorded and imaged. So that is the working principle of scanning tunneling microscope. So the animation, whatever given here. So this one is your needle tip, which is having atoms. So needle is made out of atoms, so that the tip is having a single atom. So once you come close, the electron, the current passes, and depending upon the surface structure, you get different current values. So that can be imaged, and that image is called scanning tunneling microscope. So that is what the left hand side, the scanning tunneling microscope image of carbon nanotube I have given here. So the yellow color is due to the false coloration. Otherwise, you can think of a black and white image. So this is the carbon nanotube. Hexagonal carbons are clearly visible in this image. And using this equipment, you can write letters in atomic level. Now think of the Richard Feynman and the story of encyclopedia. So if you can write one English letter in using 1000 atom, you can write entire encyclopedia into tip of a pin. Similarly, these people have written using single atom. This is a xenon atom. They have written IBM, the 3-letter IBM. Each of these things are single atom. And those scientists were working in the company IBM. So that is why they have written as IBM. So you can write, or you can, both writing and imaging can be done using scanning tunneling microscopy. So I will continue. I will move to the other slide. Let me change the slides. So now we have seen how to see or how to analyze nanomaterial. And now I will tell you in 1 or 2 slides, how do we make nanomaterials? What are the common ways of making nanomaterials? 2 common ways are there. One is top down and other one is bottom up. Don't worry about these wordings, top down and bottom up. What is top down? So the top down method, somebody wanted, or I wanted to make a small this artwork from the wood piece, or sculpture from the wood piece. So this wood piece I wanted to make. How do we make it? So we take a bigger piece of wood and carve it to this particular structure. So from starting from big piece, going to small things or required thing. So that is mean by top down. From bulk to small. So similarly, you can think of like a synthesis of or preparation of silver nanoparticle or gold nanoparticle, or maybe iron nanoparticle. Take bulk material and powder it using certain maybe mechanical way or proper way, powder it, and finally it will be forming nanoparticle. And this method is generally called as top-down method. The other method is bottom-up. So bottom-up method is what use a chemical precursor, right? Utilizing chemical reactions, we can make nanoparticles. Like for example, the nanoparticles of gold, you can make using various chemical methods. So when we say nanoparticle of gold, it is not only sphere shape, it can be rod shape, it can be cage shape, or it can be nano star shaped. So various chemical methods, like if you use a chemical sodium borohydride with chloroauric acid, like a gold precursor, and you will be ending up into nanospheres. Similarly, various different chemical pathways, different concentrations, maybe different chemical substances, if you utilize, it will lead to different nanostructures. So that is what these kinds of various structures like particles and cubes, maybe rods and other shapes, and star-shaped nanoparticle. All these things are possible from bottom-up method, various synthesis method we are using. And different colors, already we have seen various colors are possible. Now, I will move to the applications of nanomaterials. So I will start with the application which is based on biomimicry. Biomimicry is nothing but the application adapted from the nanomaterials available in the nature. We all know that God is the best engineer. In nature, best engineered materials are available. That is the same case with the nanomaterial also. Best engineered nanomaterials are available in nature. So if we can replicate some of those properties, we will be ending up in very nice nanomaterials. Maybe the first example I can tell you is the lotus effect. So whenever we think of a lotus leaf, what is the first thing it is coming into your mind? These kinds of globular water present in the lotus leaf. So why it is taking up this shape? So you think that this water is not sticking on the surface. It is not due to any oil effect in the leaf. It is due to the particular structure of that lotus leaf. So the right hand side image where the microscopic image of our lotus leaf, it shows that this microstructure, the nanostructures, the nano range structures is protruding out. Because of this particular structure, this water is not attracting to the leaf. It is repelling and it forms a hydrophobic sphere. So that is why lotus effect we are seeing. If you further look into lotus effect, so here so here it's animation which shows lotus leaf surface and water particle. So once some dust is there, what will happen? This water will take away that dust. So that means it is a self-cleaning property of lotus leaf. So whatever the bad thing or particle or dust is present is in the lotus leaf, it will be cleaned using this water globules. So that is the self-cleaning effect of the lotus leaf. So that is we call it as lotus effect. So scientists have replicated that structure, these kinds of nanostructures in, for example, maybe in the case of gloves. So this is a normal glove. So when you pour water, it wet, but the left-hand side glove is made with nanostructures which is made using polymer. So the water is not sticking there, or water is not attracting, or it is not wetting. So these kinds of gloves are useful for dealing with many maybe biological fluids, so it will not get stick on your gloves. And other applications, you can think of this self-cleaning coating in the car, nano ceramic coating. Nowadays, many places in Trivandrum as well as across the world, the car detailing centers, they offer ceramic coating, nano ceramic coating. So what is that nano ceramic coating actually? So the paint is incorporated with the nano ceramic, SiO2 nanoparticle and SiO2 as well as polymer based solution. So the picture, whatever is OD car, this car picture whatever I have shown here, left hand side is the region where nano ceramic coating has done, and the right hand side is not coated. It's a normal paint. So the left hand side, you can see that when a dirty water is gone, it is poured, so it is easily it is easily getting away. So it is not wetting, or it is not becoming dirty. The surface is not becoming dirty. This is because of this particular nano material coating. Now this mobile phone cover, many things you can think of this kinds of self-cleaning coating. the big buildings where the glass windows are glass windows are there, where entire region you can think of coating with a nano ceramic coating. So you don't have to clean that windows every time. In your room or wherever you want, you can think of these kinds of coatings. So self-cleaning coating. And the next one again from the nature. So all of you have seen lizard or gecko. So the feet, this feet, what is the peculiarity of this particular creature? It can walk through the wall, even glass wall it can walk through. So another thing, maybe you have seen this movie, one of the recent Malayalam movie where Kayangulam Kochunni, he's the thief or he's the burglar, and in his shoulder you can see this lizard. What he do with this lizard? He will throw this lizard to the big building and tie a coir or tie a thread or coir, and using that coir he will climb into that big building and for doing bulgari. And anyway, he is doing the thief bulgari for a good cause, so don't worry about that. But this what is taking away is the takeaway message is that this lizard, what is it? How is it sticking on that wall? So if you see the foot of this lizard is looking like this, and if you have a image, the magnified image, these images looks like this. So it is having these kinds of nanostructures. So these nanostructures is attaching to the wall, and little bit of vacuum is generated in this spatulae, and because of that there are several thousand numbers of these things are there, and it is getting strong attachment with the wall or the glass or whatever the surface. Similar things scientists, or you can think of, maybe this is again from an example from the movie, in the Mission Impossible movie, one of the movie, I think second movie, and this the hero Tom Cruise is walking to the wall window using this particular glove, which is called as a gecko glove. And scientists now realized, or maybe they have made this kinds of glove in Stanford University, USA. They have made this glove, and now you can easily walk through, or you are able to climb this kinds of big building. Where is this is having high application? Now you can think of our space program. If somebody wanted to walk through the International Space Station outside, if you have this kinds of glove, it is easy to hold in the station and maybe do the repair or do the scientific activities. So space, it has a lot of application, and many other applications are there. And also this is our peacock feather. So this peacock feather coloration is not only due to the presence of dye. There are some color due to the dye, but these fascinating colors are not due to the presence of dye. I mean, presence of chemical dyes, which gives particular color. It is because of this particular kinds of nanostructures, which gives some grating effect, various reflection effect. You can also think of, or people have been made these kinds of colored paints, like here. This is a chameleon paint, or painted with the car is painted with a chameleon, and chameleon is also showing various color. That is also again because of the variation in nanostructures in their body. So these are the examples. Think people have been taken from the nanomaterials which is available in the nature, and adapted that technology, adapted that particular materials, and replicated it or made it for real life application. Now I am going to other applications like the synthesis of nanoparticle and real life or other important applications. So nanomaterial can be used for sensors. So here I have written a word like a colorimetric sensors. So sensor means it will give some response. Like here, the particular example is this sensor is made using nano gold. Again, I'm taking gold because I don't want to go to many other materials. Here again, I am using nano gold. So the solution of nano gold is this color. So whatever is given here. In presence of glucose, it changes its color. As the concentration increases, the color is changing. So now you can do your glucose blood test at your home itself if you have a gold nanorod solution. So different coloration represent different concentration of glucose. So this particular experiment is done using not a nanoparticle, it is done using nanorod. So similarly, various other nanomaterials are there which gives various colors. So here I have given an example of glucose. Many other things are there like cholesterol or simply maybe the cadmium content in your water, drinking water. Cadmium is a toxic element which should not be present in our drinking water. If it present, the gold nanoparticle shows a different color. So normal gold nanoparticle color is there. If cadmium is present, it shows this kinds of color. How scientists have achieved this one? By doing proper chemical reactions, by attaching proper molecule on the surface of nanoparticle. So they are selectively detecting these elements or this particular targeted analyte. It may be glucose, it may be elements like mercury, which should not be present in water, or cadmium, other things. Many these kinds of sensors are reported. Some of them are available in the market. So the sensors can be wearable. The wearable sensor means what? These kinds of sensors which can monitor our biological activities, various biological processes. Maybe one example is the sweat sensor. So the picture is shown here, which can be stick in your body. This is a sweat sensor, and which is again made using gold and silver nanoparticle. And this particular pattern, etc., you will be able to make it. And this particular sensor, if it is stick to your palm, and which gives information about various elements, which is important to the biological physiology or biological process, like sodium content, potassium content, glucose content, etc. it can produce. So these kinds of fascinating applications are there, and people are inventing more and more on these kinds of application. So here an example from IIT Bombay, where one of my friend, he has made these kinds of shirt where supercapacitors are sticked, or supercapacitors or wearable sensors are attached to the t-shirt. It can give the real-time position, your position. So this is one of the applications they have demonstrated. They are demonstrating various other applications, and this particular wearable sensor, this flexible sensor, is made using carbon nanotube. They have engineered and their purposes and patterned it in a various method, and they are able to use it for the location detection. Like once you wear this shirt, your location can be identified like a GPS. Similarly, other things are also coming into picture. This shirt, which can be heated up when it is in cold weather, it can be cooled. I mean, it can give a cool feeling when it the hot weather. Again, this was achieved using carbon nanotube and polymer composite, and variation in its size and bundleness, it gives this particular property. I have a few more slides, maybe within few minutes, I will conclude. So again, coming to the real applications or important application, clean drinking water is a big problem in India or in every part of our country, not only our country, various developing countries. Clean drinking water. And nanotechnology is one of the best answer to prepare clean drinking water. Here, again, an example from India itself. Professor T. Pradeep from IIT Madras. I have been fortunate to work under him. So last 20 years, he have been working in these nanomaterials. In 2003 or 2004 time, he humbly started this application of nanomaterials in water purification. This is one of his first work where he utilized the silver nanoparticle. We have seen earlier silver nanoparticle, synthesis of silver nanoparticle. That nanoparticle he utilized for removing pesticide from drinking water. This endosulfan or chlorpyrifos, etc., are one of the threat or one of the important or one of the harmful pesticide present in water. This pesticide could be removed using treatment with the silver nanoparticle, and that have been commercialized, and this is one of the first commercial nano-based product available in India, mainly for cleaning drinking water or water filtration. And AquaGuard have been taken up this technology. So one of the cartridge in AquaGuard water filters is incorporated with several cartridges are there in AquaGuard, and one of the cartridges is incorporated with the silver nanoparticle, which remove the pesticide. And he further moved on to the other application for the other use of nanoparticle for water cleaning for common people. Arsenic is one of the toxic elements which can present in groundwater. So the WHO, World Health Organization's permissible limits are this. In West Bengal, several districts are severely affected with the high arsenic level content. And one of his nanomaterial, earlier the Professor T. Pradeep I have shown, one of his nanomaterial which is made using this combination, aluminum oxyhydroxide, chitosan, and embedded with the silver nanoparticle, are able to purify arsenic content in the water. And these kinds of facility, this is one facility which they have installed in one of the schools in this district called Murshidabad in West Bengal, and almost 2,000 units have been installed in various parts of this district, and every unit can purify 300 liters per hour of water. So now kids are coming to the school and collecting the water, and they are utilizing it. Oil spill removal. So I will this ship wreckage, etc., is a problem, and it will contaminate. Here one example using removal of oil removal from water using nanomaterial. You compare the left hand side thing and right hand side. So right hand side contains sugar cellulose nano composite, right hand side material. So eventually that oil you will be able to see. So earlier you maybe noticed that both this water is contaminated with oil, and you are adding the nanomaterial, and finally the nanomaterial preferentially absorb that oil, and once you remove that material, you are getting clean water. So this will be useful for removing oil spill, large oil spill in the ocean, which make a lot of problem with this kinds of marine biology. Nanomedicine, drug, or your medical, your tablet or your drugs can be accommodated or can be attached with the nanomaterial. So the only thing is that that particular nanomaterial should be not toxic. Like these are some of the examples of non-toxic nanomaterials, like dendrimers, gold nanoparticle, silica nanoparticle, all these things, or liposome nanoparticle. All these things are non-toxic nanomaterial which we can safely use. How do we utilize it? So you attach the drug or the drug with the nanoparticle. So here I have shown you 2 slides. So if you directly inject drug, the concentration of drug reaches to your affected part of the body. Maybe this is consider it as a cancer tumor. So the affected part of the body is the concentration is very less. But when the drug is attached with nanomaterials, you are getting high concentration. Maybe with this, you will have more understanding. So this is a nanomaterial solution with the drug. You inject it into your blood. And it goes through, and these white things are nanoparticles. Okay, these small things are nanoparticles. So it is getting absorbed into your tumor cell. So the drug which contain nanoparticle or nanoparticle containing drug is absorbed into your tissue, and doctor can irradiate that particular tumor region with some light. Light means maybe infrared radiation. So this infrared radiation is specifically absorbed by nanoparticle, and it will heat up, and drug is released, and eventually your cell is dead. So your tumor is dead, or your tumor is removed. Now self-healing applications are there. Maybe I will skip this thing. One example, maybe car suspension. So here the magnetic nanoparticles are used. Iron oxide magnetic nanoparticle can be used in suspension. The suspension in the car. This particular technology is used in OD car. So this is the fluid embedded with the nano iron oxide particle. When a high shock when car is experiencing a high shock, maybe a high disturbance from the road, it will automatically some magnetic field is generated here. A power thing is generated, and magnetic field is generated. As a result, what will happen? As a result, these nanoparticles are getting aligned, and your fluid become more viscous. So and more viscous fluid will give you better comfort. So this nanoparticle incorporated fluid will be giving better comfort. Then maybe this also I will skip. This is the concept of artificial leaf, the photosynthesis. Leaf is a perfect example of doing maybe the chemical reaction very effectively. For example, photosynthesis by preparing these kinds of nano materials, which is again made out of using various semiconducting thing. The carbon dioxide can be converted into useful application. And this person, Professor Sienna Rao, he is pioneered in this area. He has various materials. He has demonstrated for converting carbon dioxide into methanol, as well as converting water into hydrogen fuel, etc. Many more applications are there. So it is very difficult to explain all these things, like a solar cell application, batteries, nanofilm. Nowadays, all these, even our mask is coming with nanotechnology, which can kill the virus. Several futuristic applications, like these kinds of small nano robots can be incorporated into bloodstream, and it can go and do the surgery or whatever the minimally invasive thing. Or if your shoe is having the pressure, maybe the current can be generated using when you walk, and that will be utilized for various applications, maybe for your mobile charging, etc. And nanomedicine, which contains vaccine for all types of viruses. So single vaccine for all types of viruses. So all these things are futuristic, and carbon nanotube based elevators. So if we can create an elevator from here ground to the International Space Station, you don't have to send the rocket every time, or these materials can be used for making cloth, and the properties of nanomaterials can be utilized. The strength, graphene, etc., are having very good mechanical properties, so it can be used for making the bulletproof cloth. And this is again one video I am showing here is from NASA. They have demonstrated, or they have proposed the artificial wings which can respond to the external temperature change or pressure change. So this is again they are proposing by making using carbon nanotube and other nanomaterials. And by saying all these things, so these are the important personalities who conduct or who perform nanomaterial based research. Professor C.N.R. Rao, he's a Bharata Ratna award winner. Same time when Sachin Tendulkar got Bharata Ratna, he also received Bharata Ratna. And Padma Shri Professor T. Pradeep, then Professor Ajayan, who is maybe located in the USA. And some of you may be knowing these personalities like Dr. Ajay Ghosh, K. George Thomas, and Professor Sabu Thomas. And I know that next week Professor Dr. Ajay Ghosh is talking in the concluding ceremony. And they are the leading personalities in nano research in India. And this funding is mainly provided from the nano mission program of Government of India. By saying all these things, nanomaterial, are they safe or completely safe to utilize? So one of the novel which is based on nanomaterial, The Prey, which is written by Michael Crichton. In this one, nanomaterial is a villain. Here, not like a normal nanomaterial, whatever we have discussed. These particular nanoparticles can form any shape, or it can travel from one place to another place to as a sandstone and go there from the particular shape. So it is acting as a villain there. So the villain character is nanomaterial in this particular novel. So I'm just telling it is not for good always. It may not be always good. So nanoparticle or nanomaterial are also having environmental impact. So which type of chemical, which concentration, which duration, etc. Or if you inhale it, for example, carbon nanotube or silica particle, if you inhale it, it will deposit in your lungs. So it will cause a problem. Or this material, if you have some of the material, not all the material, it can penetrate through the body and it can cause, or if you inject this, or if you take it orally, it may cause problem. Some of them are. So biotoxicity or toxicity of cytotoxicity of these nanoparticles are thoroughly investigated before using it for any biological application. Mostly gold-based or silver-based materials are used for biological application to have less toxicity. As a summary, so we have discussed various, starting from definition of nanomaterial, synthesis, how to prepare, how to see, how to analyze, and application adapted from nature, and application which is really engineered application. All these things we have seen. So as a summary, I can say you that it is a big sciences or big science happening from this utilizing these small materials. And this is my final slide. By doing all these kinds of presentation or programs, what we expect is some motivation from students' side. Like this, maybe tomorrow you will be the scientist who is inventing whatever the futuristic application, whatever I have shown to you. And best example is for the kid scientist. This particular kid, Gitanjali Rao, he have been selected as the time cover page. So normally time cover is some actors or actors or other politicians are coming. So it is not only those kinds of person. If you do science also, you can come into the title page of the famous Time magazine. And you don't think that always scientists sit and they are old and they have a big beard and you cannot live as the way you like. So the final picture what I am showing is one of the very famous scientists who work in the field of not nanomaterial, some other organic chemistry field. So if you are like fashionable, you can do it in that way also. So if you are interested, jump into science, and you can contribute various things into the society, which is really useful for the development of mankind and the society all. So thank you very much. And again, let me thank all the organizers, and also thank you very much for your patient listening.
Thank you, Dr. Jobin, for that wonderful lecture. Before handing over to Dr. Deepthi, I would like to thank Dr. Jobin for that wonderful lecture. 5 Nobel laureates, the most eminent Indian scientists. All these people have worked in nanotechnology. Obviously, it's a complicated technology, but you have presented it to us in a very nice, simple way. So the presentation was so wonderful that I forgot that you have exceeded your time. Otherwise, I would have intervened in between. But I couldn't do that. I couldn't help doing that because of the beautiful presentation. So
thank you, sir. Thank you, sir.
So I will hand over to Deepthi for the question and answer session. Okay, Deepthi.
Thank you, Dr. Jobin, for the informative talk. You have explained the concept of nanomaterials in a very interesting way. Students are requested. Students are requested to ask question in Zoom chat box or slido.com. There are few questions in the chat box. I'll read out one by one. The first question is from Shreya Nair. Are nanomaterials biodegradable? Is it safe for our environment? Does it cause pollution?
So there is no general answer I can say. So nanomaterials, some of them are biodegradable, and some of them are not biodegradable, and it definitely cause impact to the environment if you prepare in bulk quantities. For example, like maybe carbon nanotube, if you prepare in bulk and if you inhale it, it will be a problem. Towards the last slide, I have shown you some of the aspects of biodegradable toxicity, but the one question is that like biocompatible nanomaterials. So you need to select the particular nanomaterial which is compatible to our body, like liposome or gold nanoparticle. So I cannot say always the nanoparticles are biodegradable.
Okay.
Yes. Thank you, sir. The second question is from Josh. Can we use nanotechnology to create auto building structures by future? Yes,
future sure. And nowadays this 3D printing, many of you may have read the 3D printed houses which is made in IIT Madras. So those kinds of 3D printing technologies are coming into nanomaterial synthesis also. So that will eventually lead to whatever you mentioned in the future. So it will be possible in the future, yes.
The next question is from Sunny Abraham. Can nanotechnology help to fight against COVID-19?
Yeah, so this nanomaterials, I have not touched up into that particular application. Yes, the answer is, one word answer is yes. There are a lot of work is going on with the nanotechnology, how to fight against COVID, even in drug delivery as well as vaccination. All these aspects, nanotechnology is helpful to fight with not only with the COVID, any other this kinds of communicative disease or this kinds of pandemic. Even in Trivandrum, like in ICER Thiruvananthapuram, some people are directly working to develop drug which can accommodate in nanoparticle and deliver in our body to fight against COVID. I know that in NIST CSIR also people are working towards that. So all over the world, yes, several teams are working towards that. It will take some years to come into reality. Yes.
Yeah, thank you, sir. The next question is from Alina Jacob and Milan. This is a general question. Why bubbles are always in the shape of a sphere?
Yes. Why? So this it has to be have a certain surface area, right? It has to be maybe 9 answer. You can maybe answer better.
You better.
Yeah.
Yeah, it's something to do with the surface tension.
Yes, it has to be do with the surface. It has to minimize the surface energy.
Surface tension. Yeah, it has to reduce the surface tension.
Tension. That is why all bubbles are always in spherical shape. None other than spherical. It will not be cubical or nothing like that. Yes.
So materials try to be in the lower energy level.
Yeah.
And therefore, if a liquid is in that shape, it has got lower surface energy. That is the reason. Okay, carry on.
Sir, that there were the questions in the chat box.
Yeah. Okay. Okay, Jobin. Then shall we move on, Mr. Robin?
Sir, one more question is there.
Yes.
What is spectroscopy?
Spectroscopy is the interaction of light with the matter. Okay, so light means visible light. Visible radiation contains the wavelength starting from 300 nanometer to 800 nanometer. So this light, or in other words, you can think of the different colors of light present in our normal white light. So how this particular, how this each color interact with the material. So that study is generally known as spectroscopy, and various spectroscopic methods are there. Visible spectroscopy, where it deals with the interaction of visible light with the material. There are infrared spectroscopy, where it deals the interaction of infrared radiation with the material. And all of you maybe knowing oximeters nowadays available in almost every home, right? Oximeter. So oximeter, how does it work? It works in a visible spectroscopy principle. So the red light, once you open it, switch on it, when you are seeing a red light, and it passes through your finger. And hemoglobin absorbs a particular wavelength of light. And that our oximeter determines how much light is absorbed. So that material or that process, you can call it as, or that method, you can call it as doing a spectroscopy. So our oximeters work based on spectroscopy principle.
Sir, one more question.
Yes.
What are the future scope for the use of nanography?
Several uses are there. Starting from maybe your mobile phone screen. Nowadays, it is glass like Indian tin oxide. If you replace the screen with graphene, now the flexible screens are possible. So your laptop itself, you can fold it and put it in your bag. And the bulletproof things, and the cloth which can generate electricity or which can accommodate a lot of sensors. And the graphene, this whatever the wearable sensors, I have shown one example. So those things are made using graphene, and those sensors can change the medical field a lot. A lot of applications are there, proposed applications are there. Already explored applications are there.
Okay.
Thank you, sir.
Okay, thank you, Dipti. Over to Mr. Robin.
A warm good evening to everyone. I am Arpita T. Robin of Bluemont Public School, Trivandrum. It's my first time taking a great task like Board of Thanks. It gives me an immense pleasure to thank everyone gathered here for the 7th lecture series of lectures on science and technology, which is conducted by the JMM Study Center. First of all, I would like to thank God Almighty for providing opportunities like this. And now, I would like to thank our chief guest, Dr. Jobin, the Associate Professor of Chemistry at Indian Institution of Space, Science and Technology, Trivandrum, for delivering the lecture on the amazing world of nanomaterials. Also, Sir started the talk with the superheroes, and it gave deep insights into the topic and also revealed some interesting facts on how nanomaterials can have a major impact on many aspects of human life, ranging from energy, food, medicines, aerospace, electronics, and infrastructure. Thank you so much, sir. Next, Reverend Vargas Philip, Vicar of Emmanuel Marthoma Church, Pertipara, Trivandrum, who blessed us with the opening prayer, and Reverend C.K. Titus, who is offering closing prayer. Thank you, dear Achins. And I would also warmly express my gratitude to those who have well organized the program, and that is Reverend Dr. K. Jameson, the Associate Director of the JMM Study Center, and Professor K. N. Nainan, former outstanding scientist of Vikram Sarabhai Space Center and the convener of the present program. And I would like to thank them for preparing the program well arranged. Thank you, Achin, and respected sir. And now I would like to give a deep thanks to our teachers, grandparents, and parents who have encouraged you with their presence. Without you all, the program was incomplete. Thank you, dears. Then Dr. Deepthi Shivadas, the scientist of Vikram Sarabhai Space Center, who was coordinating the question answer section. Thank you, madam. Then I thank the technical and media team comprising Reverend Ashish Thomas George, Youth Chaplain Mr. Robin Thomas, Mr. Siddhi Palchira, and Mr. George Uman, who made seamless arrangement for Zoom meeting and for YouTube streaming. Thank you all. For the welcome speech, I would like to thank Mr. Joan George Sakria of Rajagiri Christu Jayanti Public School, Kakanada, Cochin, for welcoming and introducing the chief guest. Thank you, Joan. All the ones who were singing the opening song by Joash, Johan, Joan, Ellis, and Nitsa. Thank you all for the beautiful opening song. And now, at last, the students who registered for the program, especially those who are present and who participated in the question answer section. May God bless you all who gathered here for the webinar, and may He guide you all through His true path. Thank you.
Okay, you know, every good thing will have an end. So our next talk will be the last one in this series. Of course, there has been a demand from some of you people to continue it. We will consider it for a future course of action. So we have a valedictory session in which Dr. Ajay Ghosh, who is the director of the National Institute of Interdisciplinary Science and Technology under the CSIR, and Professor and Dean of Chemical Sciences, he will be our chief guest for the valedictory message. Dr. Jobin himself has shown him as a pioneer in the nanotechnology. So definitely it will be interesting for you to listen to him. Next is Dr. Raju George, professor. He is outstanding professor and dean at IAST. The second lecture, which was my lecture, which was on space, Then on, many of you have been asking, what is the application of artificial intelligence in space program? Then I gave you the answer. You wait till the 8th lecture, because we could not locate a man better than Dr. Raju George, who teaches the artificial intelligence and machine learning in IAST. Once upon a time, it was thought that the artificial intelligence is something connected with space program, connected with automations, connected with machines that can be used, that can think or do things by itself. But today, those machines and devices are increasingly coming to our midst. And therefore, I'm very certain that all of you will be interested very much in the topic of artificial intelligence and machine learning. And there cannot be a man better than Dr. Raju, who teaches the IAST students themselves on this topic. And therefore, I request all of you and also your friends to join our program, which will have a validatory function also. And as you know, in the concluding session, we are bringing out the proceedings of all these 8 lectures in the form of an abstract, and also we will send you the certificates of participation about which our James Anachan has talked to you. Thank you very much. Next.
നമുക്ക് പ്രാർത്ഥിക്കാം. ദൈവമായ കർത്താവേ, ഞങ്ങൾക്ക് ഒന്നിച്ച് നിന്റെ സന്നിധിയിൽ ചേർന്ന് വരുവാൻ ലഭിച്ച ഈ അനുഗ്രഹീതമായ സമയത്തിനായി ഞങ്ങൾ അങ്ങേ സ്തുതിക്കുന്നു. JMM സ്റ്റഡി സെന്ററിനായി ഞങ്ങൾ പ്രാർത്ഥിക്കുന്നു. അതിന്റെ എല്ലാ പ്രവർത്തനങ്ങൾക്കായി ഞങ്ങൾ പ്രത്യേക സ്തോത്രം ചെയ്യുന്നു. ഈ സ്റ്റഡി സെന്ററിന്റെ പ്രവർത്തനത്തിലൂടെ അനേക കാര്യങ്ങൾ നടക്കുവാൻ ഇടയാകുന്നല്ലോ, അതോർത്ത് സ്തോത്രം. ഇപ്പോൾ നടന്നു വരുന്ന സയൻസ് ആൻഡ് ടെക്നോളജി ലെക്ചർ സീരീസിനെ ഓർത്ത് ഞങ്ങൾ സ്തോത്രം ചെയ്യുന്നു. അനുഗ്രഹകരമായി നടക്കുവാൻ ഇടയാകുന്നല്ലോ, സ്തോത്രം. ഇന്നത്തെ മനോഹരമായ ക്ലാസ്സിൽ സംബന്ധിപ്പാൻ ഞങ്ങൾക്ക് സാധിച്ചല്ലോ, അതോർത്ത് ഞങ്ങൾ അങ്ങ് സ്തുതിക്കുന്നു. ഇന്നത്തെ ക്ലാസ്സിന് നേതൃത്വം നൽകിയ ജോബിൻ സിറിയക് സാറിന് വേണ്ടി ഞങ്ങൾ പ്രാർത്ഥിക്കുന്നു. കർത്താവെ, നാനോ മെറ്റീരിയൽസിന്റെ അത്ഭുതകരമായിട്ടുള്ള ആ ഒരു ലോകത്തെ ഞങ്ങളുടെ മുമ്പാകെ തുറന്നു കാണിക്കുവാൻ നിന്റെ മകന് സാധിച്ചുവല്ലോ. അത് കേട്ട എല്ലാവർക്കും ഫലപ്രദമായി തീരണമേ, അനുഗ്രഹമായി തീരണമേ എന്ന് ഞങ്ങൾ പ്രാർത്ഥിക്കുന്നു. ഈ ക്ലാസ്സുകൾക്കെല്ലാം ക്രമീകരണങ്ങൾ ചെയ്യുന്നവരെയും നേതൃത്വം നൽകുന്നവരെയെല്ലാം അനുഗ്രഹിക്കണമേ. പ്രത്യേകമായി JMM സ്റ്റഡി സെന്ററിന് നേതൃത്വം നൽകുന്ന പ്രിയപ്പെട്ട ജെയിംസ് അച്ഛന് വേണ്ടിയും അഭിയോന്ന തിരുവേനിക്ക് വേണ്ടിയും മറ്റെല്ലാവർക്കും വേണ്ടിയും ഞങ്ങൾ സ്തോത്രം ചെയ്യുന്നു. ഇന്നത്തെ രാത്രിയിലെ കുടിവരവ് അനുഗ്രഹമാക്കി തീർക്കണം. പങ്കെടുത്ത എല്ലാവരെയും അനുഗ്രഹിക്കണമേ. യേശുവിന്റെ നാമത്തിൽ ഞങ്ങളുടെ പ്രാർത്ഥന കരുണയോടെ കേൾക്കുമാറാകണമേ. ആമേൻ. കർത്താവിന്റെ കൃപാനുഗ്രഹങ്ങൾ നാം എല്ലാവരോടും നമ്മുടെ ജീവിത സാഹചര്യങ്ങളോടും ഇപ്പോഴും എന്നേക്കും ഉണ്ടായിരിക്കുമാറാകട്ടെ. ആമേൻ.
Okay, thank you, Asan, for the nice concluding prayer.